Hey guys, so I'm Ethan and I'm going to be telling you about velocity, position, and acceleration. And before we work into any of these concepts, we need to go and delve into the physics side behind this, or the object's path of motion, also known as kinematics. So we have three major types of objects that a path can go through. First, an object can be dropped from a certain height. So the first thing that we need to look at is the initial velocity of an object that's dropped at a certain height. So let's take this ball right here. It's dropped from X amount of height, delta X, and we want to know how tall it is. So before we do any mathematics whatsoever, we need to look into the initial velocity. The initial velocity of any object that's dropped is 0. This is because the object's dropped, so nobody's throwing it or putting any forces on it. Pretty simple from then on. You can go ahead and you'll learn about this a little later, but as long as you know your V0 is 0, you should be good. And your total T is going to be the amount of time that it takes to go down this whole area. So dropped is pretty simple. The second thing is if we have an object that's shot. So we know that the initial velocity of an object that's shot is going to be given. So let's say, for example, this one is 32 feet a second. So we know our initial velocity is 32 feet a second. This is also when time is equal to 0. What we also need to know is what's going on and what forces are acting on an object at certain areas. Okay? So, moving on, we look to the midway path of our object. This is when time is 1/2 of its total t. Right? And this is just our total time. So right here we know that our velocity in the y direction is going to be 0. Always. V0 in the y direction is always 0. With this being said, it's also only 1/2 time. And then we need to look at our ending object of the ball. This is when it's 0 seconds. Or this is when all the time has elapsed, and the velocity final is always negative, the exact same as the initial velocity, which would be 32 feet a second. So that's our objects that are shot. And then we have objects that are shot from a height. And pretty much what these objects do is they take and they combine an object that's been shot from the regular ground and an object that's been dropped. The difference is that when we divide these up into two, we have initial velocity for the dropped object. So let's go real quick through our time. At our initial time, when t is equal to 0, our velocity naught is given. So let's say we'll go with 32 feet a second. And that's given. Then we look halfway through our object at time is equal to 1/2 t. And our velocity in the y direction is going to be 0. Velocity in the x direction is the exact same as the vector here, but you will not have to worry about that because none of these problems will worry about that. That's a physics problem. And then we know that our final velocity is equal to negative 32 feet a second. And then what we do with this is we just take these into two different problems. So first you solve it like you would the shot problem, if you can see the similarity between the two problems. But then when you add them, you have to look at this section right here, which looks at like a dropped one. So if we changed our drop equation, we'd see that our velocity initial is equal to negative 32 feet a second. And that's all you need to know.